I've collected a number of colorful objects from around the home because I wanted to compose a picture that had a lot of color in it. So what I'm going to do is use a good digital camera to take a picture, making sure that I am assigning the Adobe RGB color space that'll work as the source of the color. Now let's open that up in Photoshop and make sure that here in Camera Raw that the Adobe RGB working space is assigned. Yes, it is. Good. And now let's open this up in Photoshop. Here, let's use our eyedropper. Let's move around and look at the values that the camera has captured to make sure that there is plenty of detail in the lightest and the darkest areas. Good. Now let's print it. Have you ever noticed that when we take a colorful image like this and we print it, it usually is disappointing, even though I am calibrating and profiling my monitor on a regular basis? So what's going on here? This disparity that you're seeing is not the fault of the monitor. It's really the difference of the color space of the source, Adobe, to the color space of the destination, and that is the color space of our printer. Now, this is how it works. Let's start with a sample of 1,000 points, and I'm going to use a piece of software called ColorThink Pro from a company called Chromix in order to do this. So we'll start here. This is what the camera recorded, and we're going to end up here, the same points, but that have been squeezed. They've been moved, technically. It's called transformed to fit into the smaller space, the space of the printer. So how does that work? Well, almost every computer nowadays has software that's running behind the scenes that's responsible for knowing where each sample, each pixel of an image is and how to move it to a destination. The software is called color management software, and it's been around now for, let's say, about 20 years perhaps. So in this example here, what we're looking at is each line represents how a color space has been moved. You see that it moves in a straight line from its source, the camera, over to its destination, the printer. It's a very fast and efficient process. It's very effective as well. Now, let's do something a little bit easier. Let's take 100 samples, and now let's move it onto the side where we can see it head on like this. The samples at the top, that's light samples, and on the bottom are dark samples. Look at how they lean. The ones on the top lean down, and the ones on the bottom, they lean up. That is perceived lightness being squeezed. Colors that are really light, when they're printed, come out just a little bit darker. And colors that are really dark come out to be a little bit lighter. So what we are doing is we're compressing the perceived lightness. Now let's move up to the top. And here we can see the line sort of moving out like a spoke of a wheel. The length of the lines is the saturation or chroma. And what that means is that that larger space allowed those colors to be very saturated. But because the destination is smaller, well, that has to be compressed as well. The last thing is look at the direction of the lines where they point. And imagine, like I said, the spoke of a wheel, the center, and all these points sort of radiating around. You'll notice that they're not perfectly all pointing to the center. That has to do with the fact that the actual shape of the source compared to the destination is quite a bit different. And in order to fit them in efficiently, hue sometimes will be recalculated slightly differently than it was in the source. What the goal here is to move them all in a nice, homogeneous way that the image will be believable when it gets to the destination. But it has a lot of work to do because of the differences in the shape of the color spaces. That's sort of the tricky part and the magical part of all of this whole process, that a picture will actually work when it gets printed. So what we see here at the end is when we transform a picture from a source to a destination, we see a change in perceived lightness that gets compressed. We see a change of saturation or chroma that gets compressed. And the third thing that happens is a slight change in hue.